All right, now the other day, I got y'all discouraged, hopefully, about trig substitution. So, let's do one. I did some last night. I did a couple for y'all. I'll start with an easy one. And then I'll put a little twist to one. How about the antiderivative of x to the third over square root of 16 minus x squared. This is what we did yesterday. So if I didn't load, I thought I loaded it. I will check it, see if it's still on this computer. If it's still on this computer, I'll try to load it again. Okay? So I'm going to give y'all a couple of minutes to work on that. Don't forget your handy dandy little formulas that you need. I doubt those are still in here, but let's see if they are. If they're still in here, then nope. Somebody restarted the computer, I think. No, they're not. I think they are. No, that's yesterday's class. So I'll go to the handy dandy book and pull up, because I know somebody didn't copy it. Somebody tell me what chapter we're in. 7?
That just says 7.1.
I couldn't hear you. All I heard, I had to decipher whether y'all said 7 or not. Trig substitution, there it is. Dang old snip. And these are for the people that wasn't here, or you were too lazy to what? Copy it down. I know it was mostly people who wasn't here because nobody in here is too lazy to copy anything down. Are you? No comment. No reply. It's one of my favorite classes, believe it or not.
Chapter 1.
Okay, for those people that was not here, because everybody else copied it down. I know it's blurry, but you can look it up in your book if you want to. Square root of a squared minus x squared, the square root of a squared plus x squared, the square root of x squared minus a squared. Which one do we have? Well, minus, that's good. Y'all got minus right. So minus, so it's either this one or this one. So which one did I tell you A usually was going to be? The number or the variable? The number. So which one is it? Dang old sign. While y'all are doing that, I'm going to try to get a clearer representation of that. I'm going to freeze that for you. I'm going to try to make that a little bit better. Not that I want to do anything for y'all to help y'all pass. We need to get tough on radical Islamic terrorism. He actually said also, we need to crack down on our borders.
Wow. Curious question. You see all these Ben Carson signs laying around on the side of the road? Would it be illegal to pick a few of them up?
No, you can pick them up. Because after the person is dropped out, if nobody picks them up, they'll just sit there.
All right. You can get the T-post and everything?
Yeah, braid the T-post to me. I'm kidding.
Sell to you for $1 a piece.
Considering they're worth $5, yeah, I'll take that.
Alright.
You could have went to 3, but I'll take it for 1.
$2.50 now.
No,
I know where 5 of them are, so.
yeah, I'll take them off your hands.
I'll sell it to you for 2 points on my final grade.
Yeah, let's get Hubert fired. It'd be on me like a duck on Junebug. Junebug, what's a Junebug? It's your parents' fault.
Those things you tie the string to their legs.
Yep, and you fly them around, remote control. There we go. Isn't that a whole lot better? Don't I do some nice things for y'all?
Yes, I'm for you.
Oh. Okay, there is not caring about you. There is caring about you. Now, the first thing I would do is I would rewrite it. Because some of you may need to see the A and the X and all that good stuff. So, rewrite it. X to the third over square root of 4 squared minus x squared. And now you know what your A is. So x is equal to what? What's x equal to? Right here. 4 sine theta. Now, the whole purpose for you wanting x is so you can get dx. And dx is what? 4 cosine theta. Unless you're Miss Anthony and you try to put the negative back in there. All right, now, tell me what this is. Take your handy dandy time. And I want you to pull that to the side and substitute. Pull it over here and tell what that equals. What you're doing is you're changing all the x's into thetas. And you have to do that by substitution. And then at the end, you turn it back into x's. So you're going to come over here and you're going to say, okay, the square root of 16 minus, well, what is x squared? What is x? Plug that in. And now simplify that because there's no more x's. That's why it's called trig substitution, so you can get rid of the x's. If y'all hadn't caught on to that yet. Square root of 16 minus what? 16 sine squared theta. Now what do we do with that 16 times 16 sine squared theta? Stare at it for 15 minutes. Factor out 16. And when you do that, you should get a revelation. Unless you don't know what you're doing. And that's a possibility. No yawning in class. Where's movie theater guy? Been drinking at the movies. What's the square root of 16?
4.
And then what is 1 minus sine squared theta?
Cosine squared.
Y'all feel good about yourself.
Why did you do the square root of 16 already?
Keep it outside the box.
If you wrote it out, you
I'm sorry. Oh, God.
Get your life together.
I know. Hey, I just moved out of the ditch last week, okay? I'm trying. There.
Baby steps.
Yeah, baby steps. Equals 4 cosine theta. Like I told you, I have the notes right here. Do I follow them? Hell to the no. I got them right there. Do I follow them? No. All right, so this is equal to this. So do we have all of our things to plug in? Don't forget to do theta. Right here. And here. All right, do it. I helped you out. For those that wasn't here the other day, I helped you out, and I plug and chug. What do I plug it into? Oh, well. I'll give you a hint. Here's X. Do we have an X down here? Yeah, right there. And then you plug this up in here when you put a big 3. Let me do this. Take this, and I'll put yellow around that. So that's going to go in for this. And then I'll take my handy dandy aqua, and we will change this into aqua. And what's going to go in there?
How do you know how far you take it?
I'm sorry, I'm trying to do something right now. Don't need to be interrupted. Such disappointment. X is right here. Okay, now that I'm finished doing something on the board, what do you need, Miss Anthony?
How far do you how do you know when it stops?
Okay, first you get everything in terms of theta. Get rid of all your X's.
I mean, I know
Then,
that.
okay, you gonna let me talk or what? Then you go through and substitute, and you take the antiderivative. Then after you take the antiderivative, you have to figure out your triangle. Triangle is right here. There's the triangle. What do you mean? Well, I might have left this out yesterday. So to get your triangle, and I'm going to put a triangle here. It's really a right triangle. But to get your triangle, solve for theta, or sine theta. So sine theta is equal to what? X over what? And what is the sine? Oscar what? Had. So that's your what? Opposite over your what? Hypotenuse. And then you change after you found your antiderivative of thetas, then you plug everything back in as x's. I'll show you. In other words, this is step 1. Okay? That's called the Anthony maneuver. All right? I gave you the credit, Miss Anthony.
Oh, thank you.
Okay.
Appreciate that.
All right. Okay. So that's step 1. So what is step 1? You need to put in your notes what step 1 is to you, and text your friends. That means don't be texting while I'm talking. All right. That's a little warning shot. Okay. So, everybody with me? Number 1. So you need to go out to the side and you need to put what number 1 is to you. Number 2, plug and chug. So antiderivative of parentheses cubed over parentheses times parentheses. This is x cubed over the denominator times dx. And now we're going to take that 4 sine of theta. 4 sine of theta. Over 4 cosine of theta. And then my d theta is what? 4 cosine of theta. I'm sorry, my dx. That's step 2. Really? And mouse. Now, what have you just done? You've changed your x's into thetas. Thetas is trig substitution. Now, do we use any calculus here? No. What are we going to use now? All algebra. So do that. So we do antiderivative of mouse. I'll just try to do 4 sine theta cubed times 4 cosine theta, great, over 4 cosine theta. Now some of you are already starting to see that you can actually cancel some stuff out. You got 4 to the third, 4 to the first, that's 4 to the fourth, right? So that's going to be the antiderivative of 4 to the fourth sine cosine over 4 cosine theta. Now you take out your handy dandy red virtual pen and you cancel out what? Cosines. Don't forget your d theta. I forgot d theta. Don't forget the d theta. Okay. What else cancels? Well, one of these 4s will cancel out and make that a 3.
What is that on the bottom, on the second step? It's like 4, right there, right? Yeah.
4 cosine theta.
It's still sine to the third.
Yeah, supposed to be sine to the third. Thank you. Yeah. Now, clean that up. And that's going to give you 4. You can pull that out if you want to, but I'm not going to pull it out yet. 4 to the third sine of what? Theta, d theta, cubed, whatever. Thank you. All right, so that's step 2. We hadn't finished step 2 because we're running out of room. So we're going to take step 2 to the next page. Or, let me try it. All right. What'd you say? Because now it's starting to just piss me off, okay? Little comments, you know, I get, after about the third or fourth comment, you know, it's starting to get on my nerves. So if you want to come up here and do it, you're welcome to draw with this mouse and play with this thing if you want to, okay? You're welcome to. Anytime you want to, come on up here. Now, let's see, we've got 4, you can pull that out, 4 cubed, and then sine cubed theta d theta. And at this point, you basically have sine cubed theta. What do you do with the antiderivative of sine cubed theta? Making sure I'm on. From the previous section, what do? Well, you erase the 3, and you get cosine theta, and then you get 4/3 times cosine theta, right? Just erase the little 3 right there. Huh?
That's what I was talking about. That's the question I did that wrong.
Well, the previous section, what do you do?
Is that the previous section?
What?
Is voodoo the previous?
No.
You substitute in, forgot it.
Well, you're getting there. What do you change sine cubed into?
Sine squared times sine.
There you go. Sine squared. That's why I taught that section before this section. Yeah, and so, you know, if y'all was to put it on notebook paper, then y'all could refer back to it. You know, that's something I ought to get y'all to do. It's called notes.
Oh, right, because, you know.
Notes, yeah. Yeah, you could have flipped back there and you might have seen that, yeah. I get irritated. I'm sorry. I get irritated with this board, okay? I'm sorry. Mr. Rochester, I didn't mean to snap your head off.
I was just making a comment for I was like, talk crap, but I can't.
Yeah.
There's no two-way street here.
Yeah, well, it's my universe, okay? Yeah, it's my universe. I can talk, but y'all can't. So I apologize.
I mean, your comment just went right over my head because I still want to do it, but.
Okay. All right, well, then you'll just fail the class. All right, so now we change sine squared theta into 1 minus what? So that's going to be 4 to the third. It's 4 to the third, it's getting on my nerves. 4 to the third. Antiderivative of 1 minus cosine squared theta times sine squared theta, or sine theta, d theta, and d theta is out here where you can't see it or understand it. All right, so that'd be 4 cubed. So what is the antiderivative of 1? Oh, sorry, the antiderivative of sine. The antiderivative of the sine is the what? Negative cosine? Negative 4 to the third. Negative would be cosine. I'm sorry, yes, cosine of theta. And that would be that negative 4. You're going to pull it out, so that's going to be parentheses here. Cosine of theta. And then that cosine squared, that's u. So that's going to be cosine to the third. Theta over 3 plus c. Now I skipped about 4 steps there. So let me check to see.
That's what I got.
Okay, good. So I don't have to check now. All right, now this is the end of step 2. So step 1 is to change everything from x to theta. Step 2 is to actually take the antiderivative. So you might want to, in your notes, put a brace out here and put take antiderivative.
Can you change back into x before you take the antiderivative?
They don't want you to, because that might confuse you a little bit.
Well,
It's up to you.
The The reason I say is whenever you had the integral 4 to the third sine to the third theta.
Yeah.
There, you put that back in parentheses to the third, you have x again.
Yeah,
It'd be x to the third.
yeah, but you may not get the same answer. You got to be careful because if this is the answer right here. Okay, that's the answer. The only thing is it's not in terms of what. And y'all remember back in, yeah, just come on in whenever. That's fine. Do y'all remember back in, I don't know, some sciences that you took back in the day when they told you if you start with a fraction, you end with a fraction? Y'all have breakfast, y'all, extra sleep. I'm glad y'all got it. Okay, if you start with 3 significant digits, you what? So what did we start with? We started with x, so we need to end with x. So stage 3 or step 3 is to put it back in terms of x. Well, you need to draw your handy dandy triangle. And this is just something that helps you. You know that sine is equal to Oscar had, so that would be x, and that would be 4, Oscar had. So if you know this is x and this is 4, then what is the adjacent?
Square root of 16.
Square root of 16 minus x squared. See how it works out? Or you could do the Pythagorean theorem, spend another 5 minutes and do the Pythagorean theorem, and you get 16 squared minus x squared.
4 squared minus.
Okay, yeah, I'm sorry.
Same difference.
Look at your notes, Hubert. That's why you got them. All right, so now, I'm gonna take this and I'm gonna partition this off.
Wait, so is it 16 or 4? I'm confused.
What's 4 squared?
Okay.
Okay, 4 squared is 16. X squared, I just made a mistake. All right, now, what is cosine? Well, the little man's right here. There's your little man. And he's got his foot always on the hypotenuse and the what? Adjacent. So that means cosine. Oscar had a hunk. That would be this guy over this guy. So you got to put this guy over this guy wherever there's a what? Cosine theta. So do that. And that's the third part. So negative 4 to the third, brackets, that'd be the square root of 16 minus x squared over what? What did I say, 4? Oscar had a hump. Yeah, a hump. And then minus this 16 minus x squared raised to the what? Third power over 3 plus c.
What about the 4?
Okay, 4 over 3. Oh yeah, sorry. Over 4. Thank you. Over 3. Now we got to take this over to the next page because you need to simplify it. And what's going to happen is some of those 4s are going to cancel out here. With these 4 to the third right here, some of it's going to cancel. And I need to take this, which is not going to let me. Didn't think so. Let's see. I don't know, it's not going to let me do anything. All right, next page. Let's see if this works. Just half of it. Oh, man. Y'all have to remind me, I have no idea what. Square root of 16 minus x squared over 4 minus the square root of 16 minus x squared over 4 all to the third. This whole thing right here is to the third. And this out here, what goes out here? 4 what? 4 to the third? It's negative 4 to the third. So negative 4 to the third, brackets, square root of 16 minus x squared over 4 minus parentheses. This right here is a mess. So what we're going to do is we're going to take this square root of 16 minus x squared, and we're going to raise that to the third power, over 4 to the third power, divided by 3 over 1. And of course, you multiply by what? 1 over 3. So that cleans that up a little bit. Negative 4 to the third power, square root of 16 minus x squared over 4, minus 1, well, that'd be square root of 16 minus x squared to the third power over 3 times 4 to the third. You can get a common denominator if you want to. Let's see. But the rest of it's just mathematical. Final answer, let me see what I got. I got negative 4 to the second power. And that's because if you distribute this 4 right here, then you can cancel that 4 to the third with that 4 to the third right here. And that's what I did. I just went through and finished it. My final answer is negative 4 to the second power, square root of 16 minus x squared, plus 1/3 square root of 16 minus x squared to the third power plus c. Negative 4 to the second power, square root 16 minus x squared plus 1/3 square root of 16 minus x squared to the third power plus c. Whatever. So you got 3 stages. 1, to turn everything from x into theta. Then go through and substitute in stage 2, take everything and find the antiderivative of theta. Then after you find the antiderivative, stage 3 is to turn all the thetas back into what? X's. Or your fourth option is to what? Or your second option is to quit. And let the people die crossing the bridge across the Potomac. All right. dx over square root of 9x squared plus 4. Yeah, I'd quit.
Sorry, me.
No, I'm talking to everybody. This is too hard. Oh my gosh, we're gonna have to do tangent. You're not supposed to put tangent on homework.
Right.
Is she mumbling again?
I was gonna say something, but then you yelled at me, so I just.
I probably would. What's the question?
There's not an X, like we haven't had one without an X to be like the X and be it. You know what I'm saying? If you know the first step where you do like X equals this, yeah. That's the chart thing. Never mind. It just like it clicked. Never mind. Ignore me.
That's the second time something's clicked in here, so we're making progress. You have to be on drugs during class, but other than that.
But which? Oh.
Ooh, rewrite first.
Okay, that's a good idea.
Yeah, that's why I tell y'all to do that. Patrick, turn off the orb of confusion. Already off. For those of you that can't rewrite it, I'm going to rewrite it for you. Dx over the square root of something squared plus something squared. Is that the governor or the president? Oh, okay. I don't think I'd take either one right now. Okay. But he's at the ball game. That's a good thing.
That's what his job is.
Now be careful here because y'all gonna mess it up. The next step is 3x is equal to what? 2 tan of what? Theta. I guarantee somebody in here has x is equal to 2 tan theta. It says A is equal to x tan of theta. Read the formula. What does the formula say? A is equal to x tan or whatever, bass backwards. Okay? So what is this one?
That one's A.
Okay, what is this one? So what do you do? I'm sorry, what do you do? Yes, sir.
Before I go any further, I have to erase an entire page. I pulled the 9 and made it x squared plus 4/9.
Remember, you cannot pull across a radical.
Well,
You divided by 9.
I divided by 9 essentially, under the radical.
When you do that, your A will be 2. Will be 4.
You can do that.
Yeah, your A will be
Yeah.
2/3.
It's the same thing.
Just be careful. Just be careful, but you can do that. In other words, you factor it under the radical.
Right.
That's fine. You can do that. If I did that, somebody's head would explode. So x What's x equal to? 2/3
Tan theta.
tan theta. Now that is the little niche that I put in this problem. Yeah, so it would cause y'all to go into hysterics.
So 2/3 the way you're doing it, or the way?
Either way, you'll get 2/3. Because if you factor out a 9 right here, you're gonna get 9, and then you're gonna get x squared plus what? 4/9, and then the 4/9, you take the square root of 4/9, 2/3. So you get the same thing. All right, so dx is equal to what? You on the ball, Miss Anthony. Negative cosine. 2/3. It's easy to do secant tangent, isn't it?
See, like right there, negative stuff.
I cannot stand sine and cosine because I actually, to this day, I have to really, it messes me up. Okay, so now we've got 75% of step 1 done. Now you got to do the last part of step 1. And that is tell me what this is equal to.
So you would take that one instead of this one, the way you rewrote it, and like figure it out.
We
Never
come up.
mind.
No, plug in, you got to plug in for x.
I know there's X in the other one.
You got to plug that in right here and solve it, and that's the end of step 1. You're just continually trying to make this hard, aren't you, Miss Anthony?
I don't really know what I'm doing.
I'm trying to put it in 3 steps.
I mean, that helps.
Your lights are coming on. I mean, they're coming on, but they're just, it's kind of like when you stomp on the ground real hard and the lights turn off and on. I don't know. You ever had a house like that? You step on the floor of the house, you stomp on the floor, and the lights turn off and on. It's basically because the filament in the light bulb is about to break. That's why it does it. The vibration. Your filament's messed up. Fix it. You need to fix it. It's all them drugs. All right, so here we go. The square root of 9 parentheses squared plus 4. And what is x? Dang old 2/3 tangent. And this mouse will not write it. 2/3 tangent. So that's going to be the square root of 9 times 2/3 tangent theta squared plus 4. So that's going to be 9 over 1 times 4 over what? Oh my gosh, look at there. What happens to that 9? So you take your handy dandy red canceling marker. And those 9s cancel. And look what you're left with. The square root of 4 tangent squared theta plus 4. Factor out a 4. And that'll give you 4 tangent squared theta plus 1. And what is tangent squared theta plus 1? 4 secant squared theta, and that's 2 secant theta. So you take your handy dandy highlighter, and this guy right here is equal to this guy in terms of theta. So now, step one is done. Miss Anthony, how you feel?
I mean, I get to this point and then I get confused.
Okay. I actually do not believe this is actually working. I had to screw it up, didn't I?
You expect yourself.
All right, now do step two. Step two consists of what? Plugging and chugging in the thetas, the stuff, yeah.
So if there's no X, you're not going to use that, right?
Well, that's the whole purpose. You're trying to get everything in terms of theta. So what's, let me just do this for you right quick. Y'all like colors, so we'll do colors. Yeah, well, some of y'all do. Some of y'all like to cooperate with the teacher, yeah. dx is what? Yep. And this guy is equal to this guy. So let me take the green. That guy right there is this guy. So really, you don't have as much to plug in as you did in the last problem. Yes, ma'am. I'm Hubert. What? Yeah. I'm impressed. This is so nice. What's that for? Is that
Most of the negative signs.
Oh, okay. So it looks like to me, what is this?
These are bubbles.
Oh, the second. Oh, you're plugging in. I'm sorry.
Oh, yeah.
Okay. So that'd be 2/3 secant squared theta over 2. Okay, I'm confused now.
See, I kept it with in this
You wrote
form.
it. You kept it in that form. I see that, and that's fine. But you should get 2 secant theta. You got secant theta.
Why should I get?
You must have done something wrong.
Isn't the
Yeah, right here. Factor out the 4/9. I don't know why you didn't get the same thing.
oh but one plus tangent squared theta.
Right there. I think you got the right concept. You just something happened with the 4/9. Wait a minute. Oh, the 9. You left the 9 on.
I didn't.
9x
I
squared.
pulled it.
Okay, you did that. Okay.
I think here. Let me.
X squared. Okay, go ahead.
Okay, so-
It looks like you left something out. Or you didn't cancel it out. One of the two. Okay, so I'm going to take my handy dandy straight line maker. And I'm going to put a line right there. And now we're going to plug and chug. That's all I'm going to do is plug in my values. And that's going to give me the antiderivative. The antiderivative of dx, which is 2/3 secant squared theta over, see how nice it writes on this side, over 2 secant theta And of course, that d theta is supposed to be right here. Sorry. Okay, now, right quick, you see that the 2/3 can come out, and technically the 2/1 can come out, right? You can pull all that out. So, that's going to give you 2/3 over 2/1 antiderivative of secant squared theta over secant theta d theta, which is equal to 2/3 divided by 2/1 is the same as 1/2. The 2's canceled, and you're left with 1/3 antiderivative of secant theta, d theta, which is ain't that secant plus tangent or something? Yes.
Can you explain why you added?
Hmm?
Can you explain why you added?
The d theta, whenever you take the derivative of something, okay, what's the derivative of x? 1 dx. What's the derivative of x squared? 2x dx. But while we're working on the mechanics, sometimes we forget that, like I do. That's one of my faults. It's always there.
So after you take the derivative of something, you always have to let you know.
Yes. And I forget to do that. It's kind of like when you forget to put a plus c. It's the same thing. Let me make sure that I'm right. I think I am. Okay, good. Now, help me out. I think the antiderivative of secant is something secant plus tangent, right?
It's secant tangent.
Natural log? Natural log of secant plus tangent. I thought.
I've just got regular secant.
Go check your basic integration rules. I'm done answering questions. You asked the one question. That's all you get. Go ahead.
I fixed that one thing. Okay, so instead of,
There you go.
yeah, so,
And the 2/3 comes out, or the 2/3 you can multiply. You're going to pull all that out. When it comes out, it's going to come out to be 1/3.
2/3 comes out, and then it cancels with these 2/3, and then I just have secant theta.
And then you got secant theta, but you're supposed to have 1/3 out
Where
there.
did the 1/3 come from?
You're leaving something out up there.
Where?
I don't know. I don't do it that way. That's why I don't do it that way. Because you have a fraction out there floating.
I don't know. Okay, did I do that? First of all, did I do this right?
Did you try and do it
She's doing it the way you're doing it.
okay.
What'd you get?
The antiderivative of secant, you're supposed to get 1/3 antiderivative of
I got
secant.
the antiderivative. Oh, I got 1/3 times the antiderivative of secant.
So she's leaving something
I'm missing
out.
I don't even have the
What'd
1/3.
you got x is equal to 2/3 tangent.
Right, so
Now you see why I don't do it this way.
x equals 2/3 tangent.
That's what she's got.
dx equals 2/3 secant
That's
squared.
what she's got.
All right, so basically what you do is you plug it in. So here's dx. All right,
Yeah, I
She's
clicked
got
it.
that.
you pull the 9 out. Now see, this is actually wrong because this needs to be square root of 9
9x squared.
times.
Because that's the original. That's what you're doing. You're not plugging
But
it into the
these are
original.
equal. They're not different. They're no different.
Well, then
They're
well,
equivalent to
you
one
don't
another.
have
Because
the
you gotta
9 right
think
here.
x
Yeah,
equals
because when you
2/3
divide
tangent.
by 9, they cancel. And
Yeah,
go
but
for
you
all
have to
nine.
have it somewhere. You don't just get rid of it.
But
It don't
they're
just float
equivalent.
away.
But I didn't
It
float
needs
away.
to be right here.
I bet you I know what
9
you did.
parentheses x
It
squared
cancels.
plus.
These are definitely equivalent to one another. Like
No,
it's
they're not.
No, they're not.
That is not.
Nope.
You got to pull a 9 out.
You gotta pull a 9 out.
I did pull it out.
Yeah, but you
Right.
just floated
so
away.
This has to be
Square root of 9 parentheses
times
x squared plus.
plus
Oh,
4
okay.
ninths.
Oh, you say it and it's okay. I say it and it's the equivalent.
It's the beard.
That's what it is. Maybe I need to grow a bigger one.
Yeah. So then when you plug in tangent,
Okay.
Now
you
got it.
get
That's why
2/3.
That's why you
tan
don't have anything
theta.
out here.
Yeah.
Yeah. Okay. Got it.
All right, now fix it. Thank you, sir. Now I think I have. What do you call it? I think I've justified why you don't want to factor out right here, because you'll lose that 9. All right, so I get 1/3 natural log of, I got secant tangent. For those that are listening and not talking while I'm talking. Tangent x plus c. That's tangent x, okay? So now you're ready for step 3. Miss Anthony, what is step 3? Changing the x's into thetas, yes. So now I'm going to go over to the next page.
Oh, hold on. Is that 1/3 natural log? And then
Secant plus tangent plus c.
Yeah. Are those parentheses or is that?
Absolute. They have to be, because you can't take the natural log of a negative. All natural logs are in absolutes. No, the antiderivative of secant is this. It's in your basic integral rules. Where's your sheet that I told y'all to print out basic integral rules? Huh? You don't have it. Mr. Schaller, where is your basic integral sheet?
Well, I didn't even have it. He had it.
Okay.
But I got it.
Okay, hold it up and let everybody see it. Mr. Schaller followed his instructor's advice and printed out the basic integrals and basic derivative rules. And how long did it take you? 5 seconds? 5 seconds.
I think me and him's got a different teacher. I think that's what it is.
You know, I can't win. I just can't. Huh? Just forget it. It's my fault. 1/3, but to answer your question, that's the basic rule. Secant is natural log of secant tangent. Secant plus tangent. So here we go. 1/3 natural log of secant x, or is it x? It's in terms of x, secant theta, plus tangent theta plus c. Now, turn this into your x's. Turn it back into your x's. So that means we gotta plug back in. And I'm just gonna follow my notes. We got our handy dandy triangle, and remember we started out with the tangent. X is equal to 2/3 tangent. So if you solve that for tangent, you basically going to come out with the opposite being 2x, 3x, and the adjacent being 2. So therefore, the hypotenuse is what? 9x squared.
Wait, how'd you get that?
Huh?
Because last time I read it.
Because, let's go back to the original. To do the triangle, you have to go back to the original 3x is equal to 2 tangent of theta. All right, now solve for tangent. You always go back to that basic rule. Okay? Now solve for tangent. Tangent of theta is equal to 3x over what? Well, what is tangent from trig? Oscar had a hunk of apple. So of apple. Opposite, remember, is always the little man standing here. His foot is always on the hypotenuse and the what? Adjacent, always. So that means that this guy is the what? Opposite. So there's your 3x, opposite. Your adjacent is 2. So what's your only other thing left over? Well, you can either go back to the original right here, or you can do x squared plus y squared is equal to z squared. Do your Pythagorean theorem. 3x squared plus 2, blah, 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 and then get the square root. Z is equal to the square root of what? 9x squared, or 9x squared plus what? Plus 4. You're going to get this guy no matter what. Now you understand, it's not always going to be in the hypotenuse. Last time it was in the adjacent or whatever. It all depends on what this is right here. Yes?
If you're using x equals 2/3 tangent theta, would that make it x?
You have to get tangent right here by itself. And you should get the same thing mathematically.
Yeah,
is what I got.
2/3, you're still gonna get 3/2 times x anyway.
But you've got that floating fraction out there that's going to get you.
Wait,
It's not as bad anymore.
X equals 2/3 tangent theta.
What?
You gotta get tangent theta by itself.
I'm saying when for your opposite you have x and for your base you have 2/3.
There's no way you can get that.
Wait, what?
You're supposed to get 3x over 2. If you don't get 3x over 2, then you're wrong.
I didn't say I don't have 3x over 2.
No, I'm just saying that's what you're supposed to get. Trying to get a point across here. Try not factoring out that 2/3 or whatever y'all did. What y'all do? Factor out the
Factor out the
9. If you factor out that 9, that's causing more problems. But y'all do what you want to. Anyway, you get this no matter what. Does that help you, Mr. Silver? Swanson Silver? I get Mr. Swanson Silver mixed up. You're Mr. Silver, right?
Let me see what you got.
Okay?
Oh, I mean,
Swanson
I
Silver.
the same thing. I'm just wondering.
So, now to continue on with what we were doing, that's going to be 1/3 natural log. What is my secant? Well, my secant is, I'm just going to write it out, square root of 9x squared plus 4 over 2 plus 3x over 2 plus c. And that is your final answer. Now, if you factor it out to 9, you should have that answer. Now, how many did we do the other day? 3? We did 3 the other day. You got 2 today. So that's 5. You should have 5 in your notes to work on for your homework. All right, let's move on to something that y'all love to hear. And that's called partial what? Fractions. But I'm going to be nice to y'all and give y'all a little bit of algebra review. Because I know y'all suck at it. 3x minus 8 over x squared minus 4x minus 5. Okay, there's your, and basically when we get into the derivatives, antiderivatives, you're going to have a squiggly mark in front of this. But right now, we're just doing algebra. Now bust that up into partial fractions. All of you should be able to do that. Y'all have all had algebra. It's so simple, I'm going to get Miss Anthony to show y'all how to do it. Come on up, Miss Anthony.
I don't even know what partial fractions are.
Most people either have not covered it
I've never,
or have forgotten.
and if I have, it wasn't called that.
You can't divide it, and you can't factor it and cancel. So you just quit.
Priority
Right?
1 message
No, you
coming
don't quit.
in on secured channel.
Are you just supposed to like separate the bottom?
Okay, I'm teaching now, Miss Anthony. Okay, 3x minus 8 over factor the bottom, like you said.
Oh, okay, so I
I was trying to say that, but you were talking. X. And what does that come out to be? Dang old 1 and 5? Yeah. 5, 1, and
Incoming transmission.
5. Okay. So now this is on the left-hand side. 3x minus 8 over x minus 5 times x plus 1. So your first thing you want to do is factor everything. Now you do not want to factor out a 3 on the top. Please don't do that. All right? Equals a over x minus 5 plus b over x plus 1. This right here is called partial fractions. You're breaking up the fraction into its parts. Okay, so first we factor. And 2, you break it up into its parts. 3, multiply through by the common denominator. Multiply through by the common denominator.
So on the B side, x minus 5 over x minus 5 on the A side.
Yeah, it's going to cancel. This right here is the common denominator. So this on this side, this is going to cancel. So that'd be, I'll put a baby step in here for you. X minus 5 times x plus 1. And over here, x minus 5 times x plus 1. Now, I'm not going to go back into pre-algebra, but what is the common denominator of 3 and 7? Okay, you put them together. If they're prime, you put them together. These two are prime, so you put them one. Put them together. That's the common denominator. Okay, I'm not going over that. So that cancels. You're left with 3x minus 8. What's missing here?
X plus 1.
So, or the x minus 5 is canceled and leaves you with x plus 1. B times x minus 5. Anybody remember doing this? Okay, I got 1, 1. Okay. You remember doing partial fractions? Yeah. That's usually used with complex. All right, now take this and solve it. Of course, half the time, 90% of the class is going to say, I don't know how to solve that. Right, Miss Anthony?
Right.
So you just sit there and meditate. You got 2 parts over on the right-hand side. Everybody agree with me there? So that means, huh?
What does CD stand for again?
Common denominator. You got 2 parts right here. So if I make one of these equal to 0, then I can solve for the other one, right? That's the principle. Y'all just supposed to all say yes.
Yeah.
You're supposed to learn that back in the, when you learned how to do algebra. But I'm not going to go there. But anyway, I'm going to make x equal -1 and solve. And I'm going to make x equal 5 and solve. So do that. Plug in a -1 and solve. And plug in for a 5. Pull in plug in x is equal to 5 and solve. You'll find out. I'm not meaning that as smart aleck. You'll find out when you plug in. What?
Or just get x equals -1 and x equals 5.
I need to make one of this, you got two parts right here, right?
Yeah.
So I need to make, in one equation, I need to make this equal 0. In the other one, I need to make this equal 0. So what will make this equal 0? And what will make this equal 0? So that's where I got these two. That's where I got them. So when you plug in -1 for x, another light went off. 3 times -1 minus 8 is equal to a times -1 plus 1 plus b times -1 minus 5. What happens to the a term? And that's what happens to your a. And now you're left with solving for b. Isn't that neat? 3 times -1 minus 8 is going to be -11 equals b times -6. And divide by -6. B is equal to 11/6. So we take that up here and say B is equal to 11/6. Now solve for B, or A, which means you're going to plug in a 5. I'm going to erase this. I'm going to make sure everybody's got it written down.
So you just cancel out that A.
So you're supposed to like leave in the letters and then solve the letter, not just try to figure out what number was. I thought that's what we were doing. That's why I got.
That's all right. It's the drugs. All right, now. My gosh!
One message coming in on secured
How
chat.
long do you need? Hold on. Let me just go back and put it. I thought y'all done copied it.
Why do you like leave out the denominator?
Where did I leave out the denominator?
We have to get a common denominator, right? So we have to times everything.
Okay.
On this side, don't you still have x minus 5 over a? You see that x.
Okay, 3x. Hold on. I'm trying to talk over 3-4 people in my phone. 3x minus 8 times x minus 5 times x plus 1 over x minus 5 times x plus 1. What happens? Okay, that cancels out. Over here, a times x plus minus 5, x plus 1 over x minus 5. What cancels? You see? And that's what will always happen. Okay, has everybody got this part? Okay, now, plug in the 5. You get 3 times 5 is what? 15 minus 8 is 7. 5 minus 5 is 0, so what happens to the b term? It goes out. So you get a, and then 5 plus 1 is 6. So a is equal to what? 7 over 6. Now, you take those two numbers and do what? Plug them back into the original equation.
Is there any significance that they both have the same denominator?
No. Sometimes they'll be different. But we did multiply by the common denominator, but you're going to get, so it's sometimes they'll be the same, sometimes they won't. So that's equal to 7/6 over x minus 5 plus 11/6 over x plus 1. What this is called decomposition. Decomposition of a rational function. Now, this, if you want this, then you have to add these two. You got to get a common what? To add these two, you got to get a common denominator. And when you do, you're going to get all this algebra, and you're going to come out to this right here, or this right here. So you've just broken this up into its parts. Okay? Now, remember, this is algebra. So we're going to do another algebra just for review.
I have a question. Why did you break the things into the second, like when we break it up instead of when we multiply by the denominator? Like the equation we got when we multiply by the common denominator that you erased. Why didn't we just put those numbers into that equation?
Because this is the original right here. This is your original breaking it up into partial fractions. That's your original breaking it up. Okay?
What are you trying to accomplish by doing that?
Well, when you break it up, you can take the antiderivative of each of these. That's why. You can't take the antiderivative of this. Well, you might be able to, but when we get to taking the antiderivative, you're not going to be able to take the antiderivative of what they give you. You're going to have to break it up into its parts. Machine, problem, break it up into its parts. Y'all see a reoccurring theme here?
Yes.
Okay, I'm trying to get it across to y'all. Y'all are fighting me for it, though. Y'all are still wanting to go back to what? When is anybody ever going to walk up to us and ask us this stuff? Nobody is going to walk up to you and ask you this stuff. But besides working in a plant all your life or working in machinery all your life, how are you going to find out how to solve problems? That's how. Now, you worked in a shop all your life and your daddy was a mechanic or your mother was a mechanic. I have to say that, not to piss anybody off. But if your mother was a mechanic or your father was a mechanic and you spent a lot of time in a mechanical shop, then your problem-solving skills are a whole lot better than somebody who what? Who hasn't. But not everybody can be in a mechanical shop all their life. So what subject, for those that are listening, what subject, y'all finished? Because I'm trying to say something here. What subject in academia teaches you problem-solving skills? It's not English. I'm sorry, it's not. It's not psychology, and it's not history. Now, history tells you how not to screw up, okay? But the only subject that teaches you problem-solving skills is physics and math. Nobody will ever walk up to you and ask you to take the integral of 4x plus 9 over x minus 1 times x plus 1 times x plus 4. But this is the closest thing to taking apart a drum brake set that you're going to get, unless everybody wants to go into a shop every day and learn how to do it. That's why. Okay? It's about the easiest way I can explain it. Now, if you've never worked in a mechanical shop, you might want to do that. You'll learn a lot. You'll learn that the only thing between you and crashing is about 3/8 to a ½ inch of rubber. For all you important people that have to go 110 miles an hour on the interstate, keep it up. You'll end up decapitated one day. X plus 1. I got 1 inch of rubber between me and the asphalt. Shut up. I don't even want to talk to you. You're stupid. Talking about the freaking brake line, you dumbass. All right. All right, so do this one. If you can't do it, then you're a failure. What's a brake line? It's your parents' fault. Some of y'all Google break line. BREAKLINE. That was funny though, BREAK. Dang old break dance. All right, so let's just quit. The good thing about this one is that the bottom is already what? Factored. So all you got to do is break it into parts. A, B, and C.
That would be minus.
It's all plus. We don't, X minus 1,
Oh, okay.
X plus 1, and X plus 4.
So if I split up, good.
Yeah, that's one step you don't have to do. All right, now multiply through by the common denominator. Both sides. And while y'all are doing that, I'm going to call the roll because some of y'all are starting to self-combust. So I need to go ahead and get that taken care of before y'all explode and get stuff all over the windows.
You're gonna do this here and do the 3 different numbers.
The bottom, the 3, you're going to multiply the left side by the 3 on the bottom and multiply the right side by the 3 on the bottom, and you're going to get basically A times X plus 1, X plus 4, B times X minus 1, X plus 4, C times X minus 1, X plus 1.
Yeah, like when you're plugging it into 3 different numbers.
At the end, you're going to get 3 numbers, A, B, and C, yes. It's going to take a while because you got to use your FOIL method.
Can A, B, and C, this is a dumb question. Can A, B, and C can equal the same number, or?
You could, yeah.
Yeah, okay.
A, B, and C can be any number, any fraction, any decimal.
Each one is independent of the other.
Mm-hmm. All right, who's here? Anthony's here. Blair, I didn't see Blair again. I think he's on a 3-day drunk. He's in the ditch somewhere. Blankenship's here. Bolt is here. Brooks is here. Brown is here. Prialdi is here. Hammer's here. Khalil is here. Klutz. Didn't see Miss Klutz this morning. Loftus.
Here.
Pickens. Rochester is here. Ryder is not here. Sanders. Savasta is here. Shaller's here. Silver's here. Steely's here. Street.
Here.
Swanson is here. Trela.
Yeah.
Wagner. Waldner. And Worsey. Okay. All right. Go ahead and finish this one. It's going to take, let me just show you. First page, you find B. But then you're going to have to do all this on the next page. You're going to have to use, you can find C, but it's going to take page and a half, 2 pages, somewhere in there. Finish it up. We're still going to do some more. I'm going to try to put up your homework if I can get through the visible thing. I'm going to do that right now. And then you should be behind at least 4 things of homework you should be behind.
Alright, so just before I get too far into this, when you first plug in that one, you're doing these 2 are going to cancel.
And then you're saying you do that other for the other 2. Come here, I want you to watch this. Partial fractions. Let me just partial fractions.
Your mouse is on it.
Partial fractions. Okay, I need to make it view.
No, that's the.
I know view is on the 26th. So I need to make it view on the 26th. Is this April?
It's already due on the 26th.
What?
It's already set to due on the 26th, but you have to make it available today.
No, that's 426.
Yeah.
That's I wanted 326. I'm gonna do that first. All these people in line for work. Oh my God. Where did it go? I lost it.
Right there.
Partial fractions. 326. Is this April? 3 see, man.
That's 4.
So I need to go back 1. 326.
So basically you're saying 2/3.
I gotta change the stupid view. So I gotta change this to, what is your other ones? 112?
Today.
Or today?
24th.
324. There, now can I change this? 326. Okay, that's good. Now, what do y'all need right quick? Bonus?
Yeah.
Okay.
Thank you.
What do you need?
I was just want to see if you could show me where that one was from this Tuesday.
I've got to, I've evidently, it didn't post.
Incoming
I
transmission.
don't know why it didn't post. I'm going to fix it to post. Oh shoot, I got to turn it off. Hold on a minute. Darn, I forget to do that. I'm going to see if I can find one from last semester and post it. How about that?
Okay.
That way it'll help you out.
All right,
All right, sorry it didn't post. I don't know why it didn't. I'm a loser.
Got law for water. Copy of this.
That came from downstairs.